Hi everyone, and welcome to Week 6 of BUSS420 Project Management. It seems like I say it every week, but Week 6 is another busy one. Here's the checklist for the week. We have some reading to do, another two-part discussion on managing constraints and resource issues with multi-project environments. For our first assignment, well, those will be problems from chapters 11 and 12. We have a case study from chapter 12, and then our second installment of the final portfolio project, and we'll conclude the whole thing with a weekly reflection. Let's dive into some of our main topics for the week. And here's our reading for the week. It all begins with some lectures up in our Angel classroom, and we turn to our textbook, Chapter 11, Critical Chain Project Scheduling, CCPM. Now, that is based on the theory of constraints and how they can, if not properly managed, cause project delays, and how teams waste what they'll call safety buffers, and you'll read about that. And then the critical chain solution, or how they approach the problem with a slightly different aspect than what we've learned this semester. And since this is all about resource management, Chapter 12 will be right there, where we'll talk about the basics of resource constraints, resource loading and leveling of your project schedule, and managing resources in that multi-project environment. Now, looking at some of the topics in Chapter 11, it begins with some problems with PERT CPM. Now, there are complications that happen to begin when we start to account for resource availability. You've seen this example before, where we have a very simplified project schedule with 4 different tasks or nodes, A, B, C, and D. We have 2 paths through this network, the red one being critical, and then there's a second path with a second activity, B, that is not critical. And here's where the problem lies. What if activities B and C have to be done by this one expert individual? That's right. Even though the logic says that we can do them at the same time, we actually have to do them sequentially because of that resource constraint. So we can't just make our schedules in a vacuum. We have to understand the impact that resources have on our schedules. And that's where in our textbook we turn to this theory of constraints, because resources is just a specific constraint. Now, what we want to do is identify the system constraints, and system, you can think of it as that overall project schedule. We want to uncover the principal constraint. Is it time? Is it resources? And don't get bogged down with identifying the little problems. It's that 80-20 rule. The next step after identifying the primary constraint is to exploit it. And all that means is to focus all activities in terms of that constraint. And the example we had is, if you only have one experienced programmer, that's my constraint, and I have to schedule their work first. And we'll subordinate everything else, and that's an example of scheduling their work first, right? Of subordinating everything else so that only the primary constraints are of importance. So after scheduling the activities of that experienced programmer, only then should you schedule other activities. The next step is to elevate that system constraint, and that means to seek to solve the root problem. Well, the root problem is I only have a single expert programmer. Maybe a solution to that is to hire additional experienced programmers. So after we're done exploiting our system for that first constraint, we'll repeat the process, right? Perhaps we only have one automated software test program, and we need to work on that as our next constraint. Ultimately, we're optimizing the entire system, our entire project schedule. Now, another topic in Chapter 11 are looking at some of the causes of delays in your schedule. Sometimes it's simply an overestimation of individual activity durations. Padding estimates of individual activities or safety comes into play, and you'll read about that. Now, project manager's safety margin, it's another buffer that a project manager will often add into their project schedule, and that is aggregating individual activities and then adding a pad of their own. And then finally, top management comes in there, and they mandate completion dates, often with across-the-board cuts. Everything gets cut, 20%, my manager would say. So there's many roots or causes of delays in your projects. Let's take a look at what's going on here with an illustration. Let's say you have a schedule with 3 activities, A, B, and C, and there you can see the completion date is at day 9. Well, the first thing that happens is that those resources assigned to those activities, Well, they might pad each of them so that actually each activity is itself padded, and you can see our schedule delay out to day 15. After the individuals are done, well, heck, it's my turn as the project manager to add a safety buffer to the overall project, and now I'll go to my manager and say, hey, there you go. I think we'll be done these 3 activities in 20 days. So where we go from that original estimate of 9, we can easily double the time that we're allocating to complete this set of activities. Sometimes delays, well, they're not just an act of putting a schedule together, but they're the result of people wasting time, and there's something named after you, student syndrome, and that's the tendency to put off the maximum effort until the last possible moment, right? I get a lot of assignments that are posted up the last thing on Saturday night, an example of the student syndrome. Now, there are a few other areas here that the author identifies of wasting time, right? Failure to pass along positive variation, negative consequences of multitasking, and we'll discuss that in our discussion forum this week, and parallel activities that merge that can't be taken advantage of in time. You'll read about all of that in our textbook. So let's take this theory of constraints and try and put it into practice, and Elijah Goldratt did that with something he calls the critical chain solution. And that's to use optimistic task estimations and create project buffers as contingency reserves. Now remember, when we did task estimation, there was the PERT way of doing that, which is to take 3 estimates, the optimistic, the pessimistic, and the most likely. So here with the critical chain solution, he's saying, I think we want to use the optimistic task estimations, and then we'll add a project buffer, and you'll see how all this plays out in the following illustration. So we can have 3 estimates per task, right? Here, task A, a pessimistic estimation. And here is the most likely estimation for that same task. And here is the optimistic estimation. And our critical chain solution says this is the one that we're going to start with. So let's take a look for a second at what PERT CPM would say. They would say for task A, we use this formula. Optimistic plus 4 times the most likely plus the pessimistic, all divided by 6. And this is our estimate for that first activity. We do the same for the second activity, B, and the third activity, C. Now we go and we run to our manager and we say, we're going to finish that set of activities on day 11. But what happens right out of the bat is that task A is delayed for some reason. We took a look at some of those causes of delays. Now I've got to go back to my manager and say, ouch, take a look, our schedule is moved. So how does critical chain seek to solve this problem? Well, we're using that optimistic estimate for A, but we're going to allocate a portion of our project buffer to help us as a safety buffer in case it were to delay. After all, it is an optimistic estimate. We should have some safety buffer. Now we do the same for task B, taking the optimistic estimate and adding to our safety buffer. And task C, again the optimistic estimate and adding a little to our safety buffer. So now we return to that situation where I run back to my manager and I say, we'll complete those 3 activities on day 11. And now when task A delays, well, I don't have a new end date to report up to my manager. I can tell him that I've used part of my safety buffer, but now we can raise the attention on completing tasks B and task C and giving those parts of the project additional attention and priority. So monitoring our safety buffer, our project buffer, can really help us as a project manager in order to monitor the overall progress and prioritization of activities in our project. Well, enough about our reading for the week. Let's take a look at one of our first things to do, which is discussion, and that'll be on resource management. And we'll talk about what are some of these constraints that can affect a project, making scheduling and planning difficult. And we looked at a few of those right here in this video. And what are some solutions to dealing with resource issues in that multi-project environment? Our first activity for the week are problems in Chapter 11 and 12. Now this is due on day 7, which is Saturday by midnight Eastern Time, and please post your attachment to the Dropbox right there in Angel. Now you're asked to do 3 problems in Chapter 11 and 5 problems in Chapter 12. Now for some of these problems you have to show networks of schedules. And please, you can do this using any Microsoft project program that you have. Some of the more daring of you will try to do this in projects, and I really encourage that. But some of our examples from the book are simply drawn using boxes and text, so PowerPoint or Visio or Excel have worked fine for students in the past. Now, the next activity is a case study from Chapter 12, and this is also due on Day 7, which is Saturday by midnight Eastern Time. And please post your attachment up in the right Dropbox in Angel. And now this is all about the problems of multitasking. And there it'll ask you to examine the relationship between project activity scheduling and resource availability. We saw a great example of that right here in this video. Now you'll go on through that case to answer the questions 1, 2, and 3, and please cite scholarly research and resources for all your case studies. One of the last activities for the week is the second installment of the portfolio project, due on Day 7, Saturday by midnight Eastern Time, as an attachment right there in the Angel Dropbox. And here you'll continue your work from last week and complete the sections Week 6, building a WBS, we've done that previously here in this course, scheduling the activities and allocating the resources, just what we've been talking about all week. Now this will require you to complete a Microsoft project schedule, starting with the template provided for you, so please be sure to start with that template. Now there's a separate video up in Angel that can help walk you through this part of the activity. So, like I said at the beginning, it's another busy week. 2 chapters to read, a 2-part discussion question. We've got a number of different activities, from problem sets in both of those chapters to a cool case study. And then finally, our second installment of the final portfolio project before you get to that weekly reflection. And as always, if you have any questions, email me, my address is right there, or post them up to the appropriate form right there in Angel. Thank you all, and let's have a fantastic week.